A shielded cable is an electrical cable of one or more insulated conductors enclosed by a common conductive layer. The shield may be composed of braided strands of copper, a non-braided spiral winding of copper tape, or a layer of conducting polymer. Usually this shield is covered with a jacket. The shield acts as a Faraday cage to reduce electrical noise from affecting the signals, and to reduce electromagnetic radiation that may interfere with other devices. The shield minimizes capacitively coupled noise from other electrical sources. The shield must be applied across cable splices. In shielded signal cables, the shield may act as the return path from the signal, or may act as screening only. High-voltage power cables with solid insulation are shielded to protect the cable insulation, people and equipment. Signal cables. The best method to wire shielded cables for screening is to ground the shield at one end of the cable. Traditionally, there existed a rule of thumb to ground the shield at one end only to avoid ground loops. In airplanes, special cable is used with both an outer shield to protect against lightning and an inner shield grounded at one end to eliminate hum from the 400 Hz power system. Applications. The use of shielded cables in security systems provides some protection from power frequency and radio frequency interference, reducing the number of false alarms being generated. The best practice is to keep data or signal cables physically separated by at least 3 inches from heavy power circuits which are in parallel. Microphone or signal cable used in setting up PA and recording studios is usually shielded twisted pair cable terminated in XLR connectors. The twisted pair carries the signal in a balanced audio configuration. The cable laid from the stage to the mixer is often multi-core cable carrying several pairs of conductors. Consumer use screened copper wire with one central conductor in an unbalanced configuration. Also see high-end audio cables, power cables, medium and high-voltage power cables. In circuits over 2000 volts, usually have a shield layer of copper or aluminium tape conducting polymer. If an unshielded insulated cable is in contact with earth or a grounded object, the electrostatic field around the conductor will be concentrated at the contact point, resulting in corona discharge and eventual destruction of the insulation. Leakage current and capacitive current through the insulation presents a danger of electrical shock. The grounded shield equalizes electrical stress around the conductor, diverts any leakage current to ground. Stress relief cones should be applied at the shield ends, especially for cables operating at more than 2 kV to earth. Shields on power cables may be connected to earth ground at each shield end and its splices for redundancy to prevent shock even though induced current will flow in the shield. This current will produce losses and heating and will reduce the maximum current rating of the circuit. Tests show that having a bare grounding conductor adjacent to the insulated wires will conduct the full current to earth more quickly. On high current circuits, the shields might be connected only at one end. On very long high-voltage circuits, the shield may be broken into several sections since a long shield run may rise to dangerous voltages during a circuit fault. There is a risk of shock hazard from having only one end of the shield grounded. The maximum recommended shield potential rise is 25 volts. IEEE 422 and 525 lists the cable lengths that would limit shield potential to 25 volts for a single point ground application.